Welcome to UVU CS3060, Lecture 1.2, where we discuss memory and memory management. So at this point, we've come to the conclusion that we need to have this operating system. The operating system acts as an intermediary between the computer hardware, specifically CPU and memory at this point, and the system applications and application programs that run in the user mode or the unprivileged mode to accomplish tasks that the user needs done, like compiling or editing text or perhaps managing a database system. So with this, we have four components to the computer system. The hardware, which is managed by the operating system. The operating system helps the application programs get access to those hardware resources, and each application is run by a user. Now, stop for a second and consider what a user is. Users are generally people like you and me at the keyboard trying to get something done. But users can be other things as well. For example, we could have a sensor that is indicating the presence of somebody at your doorbell. And that sensor can send input to an application on a computer system that would be able to process how to react to somebody at your doorstep. So it can be a device, but a user can also be another computer, such as with this database system over here. This user might be on another computer requesting data from the database. You've actually used one of these programs, not a database program, but when you've logged into the server, the classroom server, you used a terminal program, such as PuTTY or SSH. That terminal program was a piece of software that contacted the classroom server and manipulated the classroom server through a program called SSHD. And so we have here a case where one computer controls another computer through an application. Now, when it comes to managing these resources, there are two things that need to be considered when designing an operating system. The fairly simple part of managing a resource is how that resource is accessed. For example, if I need to transition from one process to another in the process scheduler, how we do that is we save the registers for one process, and then we load the registers for another process. The mechanism is almost very straightforward. The real trick of an operating system is the policy. The policy is whether something should be done. Now, what is the policy for the instruction that saves and loads CPU state? Well, the policy for that is it is a privileged instruction, and user processes should not have access to that. Now, are there situations where it is appropriate for a user space process to change CPU state? Why, yes. In a virtual machine is a user space process, but that user space process actually has a kernel that it's running along with its own user space processes. So certain policies need to be in place to allow that user space process to manage process state within its particular context. So the policy for that becomes quite tricky. Now, we've talked about multiprocessing, that an operating system should be able to load multiple programs into memory. And those programs themselves should be able to access their own memory, but should these programs be able to access the memory of other programs? That's a really good question. In general, the answer to that is no. You should not allow one program to access another program. I talked in the previous lecture about accessing memory of a password program. That should not be allowed. But there are exceptions to this policy. Perhaps two processes need to share sections of their memory, and an operating system should be able to manage that. Now, process memory is also virtualized. Every process gets what it considers its own address space. And in modern operating systems, that address space looks like it owns the entire memory. Now, the policy is not to allow access to other process memory. You should be able to provide a mechanism. You should be able to give permissions to that process, be able to program that. And we'll actually talk about shared memory systems when we get to that section. Now, also something an operating system is capable of doing is actually giving the process the view of memory as if it owns even more memory than is physically available. We call this virtualized memory. So virtualized memory, it really isn't an honest representation of what physical memory is, but to a process that doesn't matter. Process can go ahead and allocate whatever memory it needs, and the operating system will manage that various ways using a virtualized memory system. So at this point, I recommend you go take a look at the demonstration video named Keeping Up Appearances, where I demonstrate how different processes may have the same address, may have what appears to be the same address space, but they are separate from each other.